Now, let's look at some past paper questions regarding solution of triangle. A word of warning before we start the question. The DSC solution of triangle question will not be as straightforward as those IGCSE question. In IGCSE, you may have a question exactly like this. Alright, given some of the information, you find the unknown directly using the sine formula or the cosine formula. But not so much in DSC. In DSC questions, somehow there are always twists and turns. You have to kind of divide the question into stages or make some, additional contribution before you can solve the question. And there are sometimes traps and misleading things in the question. Now let's take a look at this one, right? Alright, there's a big trap in this question. So we have the triangle ABC, alright, ABC. And the line ratio, they are 8, 15, and 17. Alright, though it says it's a ratio from 8 to 15 to 17. We can just let the line be 5, 15, and 17. Alright. We want to find the ratio cosine A to cosine C. Alright. So you may find it simple, or I just use the sine formula, right? So we have sine A divided by 15 is sine C divided by 8. So A over C will be 15 over 8, right? So the answer goes to C. Now, unfortunately, that's very wrong because the question asks for cosine A and cosine C, alright? While what I'm using is the sine formula. So 15 over 8, 15 to 8 is sine A to sine C instead, right? So now, in fact, we want to find cosine ratio, not the sine ratio. So to find the cosine ratio, fortunately, we have all three lines. So we can invoke triple S cosine formula. We can invoke triple S cosine formula. Alright. To find cosine A, we have 8 square plus 17 square minus 15 square divided by 2 times 8 times 17. Alright. That's how we find cosine A. Okay. And that simplifies into 8 over 17. By similar token, we can find cosine C. That would be 15 square and 17 square minus 8 square divided by twice 15, 17. Alright, and that simplifies to 15 over 17. Alright, it's very important that you know which sign goes where. Alright, you have to know what place shall this number go. Right, in order to find the triple S cosine formula. Anyways, the ratio between these two cosines, cosine A to cosine C will be A divided by 17 to 15 divided by 17. So the answer goes to A to 15. 8 to 15, the answer is A. Alright, so that's the first question. Please remind that it is the cosine. Alright, do not use the sine formula for this question. So this is the first one. Alright, now next up we have this one. We have a rectangle. We have the dimension of the rectangle. It goes, the red line is 28. Alright, so is this red line, right? Because it is a rectangle. Alright, so is this one. And then the blue line here will be 21. Alright, the blue line here will be 21. So what else do we have? We have, this green line. This green line AE is 30. Alright, so let's put back the numbers. This is 28. Alright, the blue one is 21. The green line is 30. Now we want to find the purple line DE. Alright, we want to find the purple line DE. Now the first thing to do is what I call a focus triangle. We want to find a focus triangle. Alright, the focus triangle is the one that contains your answer. That in this case, that would be the triangle containing DE. Now there are two candidates to this focus triangle. We can pick this one, triangle CDE, or we can pick this one, triangle ADE. So which one to pick depends on how much information you can gather on that triangle. Remember the first idea in solution of triangle. Given any 3 pieces of information, you can find the other 3. So we must get the triangle with 3 pieces of information, right? Triangle ADE, we have 1 line and 2 lines. All we need is 1 more angle. Triangle CDE, we only will know 1 line. You do not know any other information. So maybe triangle ADE is the better starting point. Alright, that is our focus triangle. Okay, we start thinking about the question in this one. So like I said, you have two lines, right? All you need to do is to find one more angle. So which one is more readily available? These three angles. Alright, it turns out that the orange angle here is the target. Alright, we can fix this orange angle here because this orange angle is the tangent ratio between 28 and 21. We have tangent theta is 28 divided by 21, right? It is the right angle in the rectangle, alright? 21 is in blue, alright? So tangent theta will be 28 out of 21. So we can find theta. With theta known, we can use the SAS cosine formula, alright, to find the purple line. The purple line DE squared will be SAS 21 square, 30 square, alright, 30 in green, alright, minus 2 times 21, 30, and then we have cosine theta. Now unfortunately what we have is tangent theta. So how do you obtain cosine theta from tangent theta? There are two ways. Number one, you can use the calculator. You can use the calculator, find out what tangent is. Find out what theta is. So calculator goes that theta is 3.13 degrees, and then you can find cosine theta, right? Now, but this path is only an approximation, all right? The answer here, they demand exact value, all right? But it's an MC, you can cheat actually. You can use the calculator to find the approximation and see which of these answers they are nearest to your approximation, right? It is an MC question, so you can cheat on this one. But if it is not an MC question, if you need the exact solution, then this calculator approach is not work, alright? Only works for MC or is only for approximation, alright? If it is a paper 1 question and it demands exact solution, this way does not work. You have to use the triangle to get the cosine value. We know that tangent theta will be 28 divided by 21. Alright, so we can use Pythagoras Theorem to find out the missing line will be 21 square plus 28 square, taking the square root. Alright, so this hypotenuse goes to 35. So from here, we know that cosine theta will be 21 divided by 35. Alright, so you can use this answer into the cosine theta here instead of using tangent theta. Okay. So if you put all these numbers into the equation, that we have DE will be the square root of 585. Alright. Now mind you, let me remind you again, you have to put back the DE here. Alright. If you just put equals to 585, then by default that means DE square equals to the square root of 585. Alright. You have to put back the DE here. Okay, but there's no answer matching 585, so we have to further simplify it into it is 9 times 65, alright? So we can change it to 3 times the square root of 65. This A is the answer. So let us review this question. There are two important things in this question. Number one is the focus triangle. Is the idea of the focus triangle. We want to obtain the triangle that we have 3 pieces of information. If you have 3 pieces of information, you can solve for the other 3, alright? And this is the first point. The second point is how we obtain cosine theta from tangent theta, alright? We know that the tangent theta is 28 over 21. How do we obtain cosine theta, right? We can use a right angle triangle, or we can use the calculator. The calculator is only good for MC question or approximations. But the exact solution, you have to do it with the right angle triangle. Is that right? So that is the second past paper question. Alright, let's move on. Alright, so we have the third past paper question. Now, so many numbers here, right? Let me take a look at them one by one. So we have AB, the orange line is 24. Alright, this orange line is 24. And then what else? We have AD, this red line is 40. Alright, this red line is 40. What else? we have this BD is 32, so this green line is 32. It looks like a right angle triangle, but I'm not sure, right? And then what else? We have CD, right? CD, this purple line. This purple line goes to 68, all right? So I suppose BC is the missing part. Maybe the question is asked for BC. All right, true. The question is asking for what is the length of BC, right? This blue part. This blue part, right? Now, like I said, I suspect this is a right angle, right? I suspect this is a right angle. Now, the question will be very easy if it is a right angle, right? I don't know. So maybe it's worthwhile to spend like 5 seconds to check on it. So can you invoke the converse of Pythagoras Theorem to check that 40 square, is it the square of 32 plus the square of 24? If it is, then the angle is a right angle, and we have right angle triangle. Is it a right angle triangle? 40 square, the red line, is it the square of 24, the orange line, plus the square root of 32? Indeed it is, all right? So it is a right angle. If it is a right angle, so is this one. So the blue line is simple, all right? The blue line, we have BC square equals to 68 square minus 32 square, all right? Now, this is the easy way out in the question because we make the observation, all right, that it might be a right angle triangle there. It may be a right angle there. So the answer goes to 60, all right? This is the answer, all right? Right, so D is the answer. Right, this question is simple because, like I said, I made the observation that there might be a right angle triangle there, right? So making use of that right angle triangle, I can, turn them into Pythagoras Theorem, and the question is much easier. Now, what if I fail to observe the right angle triangle? What if I fail to observe the right angle triangle? Can we find this answer without noticing the right angle triangle? You can, because there are 2 triangles in this question. One is the red, orange, green one. All right, we have this triangle. All right. On the other hand, we have the red, purple, and then blue. Red, purple, and then blue. All right, blue and orange to be precise. Right. Now, these 2 triangles, they share the same angle. Right, the angle here, they are the same. So we can invoke the cosine formula 2 times. All right. The first time we have cosine theta will be 24 square plus 40 square minus 12 square. All right. Divide by twice 24 and 40. All right. In the first triangle. All right. This is how we express cosine theta. All right. In this triangle. And then we can do that again in the second triangle. We can do that again. Then we have cosine theta will be the whole AC. All right, I don't know how long is AC, so I have to put that in AC square. All right, plus 40 square minus 68 square. Divide by twice AC 40. All right. So we can use the cosine formula to express the same angle in 2 different triangles. Of course, this cosine theta is the same as that cosine theta. So we can equate the 2. All right, and then we have a quadratic equation in AC. Solving for AC, we can find the, it turns out that, I'll skip the details. It turns out that AC equals to 84 or minus 36, all right? So if you subtract 24 from 84, we have BC equals to 84 minus 24. So the answer goes to 60. All right. Of course, the minus 36 is rejected. We do not have negative lengths. All right. So that is the hard way. All right. When you do not observe so that's how observation. A good observation goes a long way in some of these tricky MC questions. All right. On top of the black line is the easy way when you observe that there is a right angle triangle. beneath the black line is the hard way, alright? But that is useful if you do not observe or there is no right angle triangle, in fact, alright? You can try to express the same cosine theta in two different triangles, alright? And then you equate the two equations, and then you can solve for the answer of AC, alright? If you have AC, then you subtract 24 from AC, then you get BC. Alright, I hope you know both methods so that you can use the one that is most applicable to the situation. Alright. So next up we have the last question, right? Now first of all, it is an equilateral triangle. Now there are so many things packaged in this word equilateral. First, it means that the three red lines, they are the same. Alright, equilateral. Second, it means that all these red angles, what are the values of these angles? They are all 60 degrees, right? There are so many things embedded in this one word, equilateral triangle. Now, moreover, we know that AD is 4, alright? So this tiny blue segment is 4 units, alright? 4 cm. And then CDE, this green angle here, is 60 degrees, okay? This angle is 60 degrees. Oh, so is the red one, right? Maybe I put it in red as well. Same angle, I put them in the same color. We want to find CE. We want to find this green line, okay? Oh, did I mention the red line? They are all 16, alright? They are all 16 for the red lines, okay? Okay, so like the previous questions, there is an easy way, there's a hard way, alright? Once again, the easy way demands a lot of observation. If you observe the weak point, if you observe a feature, a weakness in the question, then you can solve the question very quickly. Alright. If not, you have to do it in brute force. You have to do it the hard way. Alright. So let's try the hard way, right? Now, CE is the blue line. So I think doubtlessly the focus triangle, remember the focus triangle technique I shared with you before? The focus triangle will be triangle CDE, right? This is the only triangle that contains the green line CE. So we need 3 pieces of information. Good, we have the 60 degrees. What else do we need? We need one more line and one more angle, or maybe 2 more lines, right? So let's see what do we have in this focus triangle. Say, do we know DE? We might not know DE. We may know DE because we can find DE with the let me color DE, right? DE is the purple line. We can find DE because we have this triangle here, alright? We know this is 12, this is 60 degrees, but we don't know anything about this one. So this is not good enough, the purple line. Well, do we know AD, alright? Well, we do know AD because we have SAS in this triangle. We know the 16, we know the 60 degree, we know the 4, so we can find AD. We can find CD, I mean the orange line, right? So we can find CD. So there's one more piece of information. We have CD, we have 60 degrees, we need one more thing. Perhaps the purple line, perhaps one more angle. Like I said, the purple line is a dead end, so we have to look at this angle, right? We have to look at this yellow angle. This yellow angle will be 60 degrees subtract from this yet another pink angle, alright? So the pink angle, once again, we can discover the pink angle in the triangle ACD, am I right? So now that's the plan now, alright? That's the plan, right? In triangle CDE, in triangle ACD, we can find the orange line. Find the orange line CD, right? We can also find the pink angle. What is the pink angle? The pink angle is angle ACD. With angle ACD, we can find the yellow angle. The yellow angle is DCE, alright? I am poor at this vertex naming. I would rather think in terms of colors, alright? So that's the plan. In triangle ACD, we can find the orange line CD. We can find the pink angle ACD. With pink angle ACD, we can get the yellow angle. With the yellow angle, the orange line, and also the 60 degrees, we can use SAS. We can use SAS, right? This is angle CDE. is 60 degrees, right? So with all these three, we can use SAS cosine formula to obtain CE, right? That is the battle plan. Alright, do you get this? Before you do it, you have to have a plan. Alright, now let's look at the plan again. Alright, you may pause the video, go back, look at this plan, and try to finish this question. Alright, see how much time do you have to spend on this one. Alright, in this triangle ACD, you get the orange line using SAS, right? Using SAS to get the orange line CD. And then once you have CD, you can use triple S cosine formula to get the pink angle ACD. Once you get the pink angle, you use 60 degree minus, and then you get the yellow angle DCE. So now you have the yellow angle DCE, you have the orange line, you have the 60 degrees, oh I'm sorry, it should be ASA, right? You can use ASA to find the green line CE. Right? You may pause. I'm not going to do this for you. If you want to, you can pause the video and try to find the answer. Alright, so I suppose you finished finding the answer. If not, you can pause the video and do that again. The answer is D. Alright, CE is 13 cm. 13 cm. Okay, well, this is it. Oh, but not yet. I said, did you remember that I said this is an easy way, right? Now, this is the hard way, right? Now, the easy way demands a lot of observation power. But if you can spot the easy way, you can finish this question in literally seconds. Now, the easy way is to spot a pair of similar triangles. Alright? Now, do you notice this 60 degrees? Right, I put in solid red, it's just the same as this 60 degrees. Now here comes the angles. I hope I have sufficient colors to do that, right? Think about this angle here, right? Let me call it angle theta, right? And also think about this angle here. Oh, I'm literally running out of colors, right? Let's call this alpha. Now around here, what can you say about alpha, theta, and 60? We know that alpha plus theta plus 60 degree is 180. They are angles on the same straight line. Alright? It is 180 degrees. Now, do you recall the pink angle? What can you say about the pink angle? We have 60 degrees plus alpha plus the pink angle, right? It's also 180 degrees because it is angle sum of triangle. Alright? They all add up to 180 degrees. So what does that mean? That means the pink angle equals to theta. Alright, so this theta in fact is the pink angle. So now we have a pair of equal angles. We have the triangle here is similar to the triangle here because of two angles, because of asimilarity. Alright, we have these two triangles, they are similar. So this is theta, right? So we have to put it formally, we have triangle ACD is similar to the triangle BDE, alright, because of asimilarity. Two angles, they are the same, the red angle and the pink angle. For similar triangles, corresponding line, they have the same ratio. So we have 16 divided by 4. 4 is the blue line, alright, equals to 12. BD is only 12 units. Alright, equals to 14 minus 4, 16 minus 4, alright, divide by BE. So right away we have BE equals to 3. With BE equals to 3, we can finally have CE equals to 13, alright. Right, so this is how we did it with similar triangle. Now once again, if you are not observant enough to get that similar triangle, you can still do it in the conventional solution of triangle way, but it will be much slower. Alright? So this is quite a long video, but I hope you can get the idea on DSC solution of triangle questions. Thank you.